This is how to identify rocks. First, you start off with the rock cycle. Sediments are formed by the rock being weathered and eroded to different places on the earth. As the rock builds up, it forms layers that are compacted together to become sedimentary rocks. Sedimentary rocks are altered by heat and pressure, and they become metamorphic rocks. When the metamorphic rock melts and then cools again, the melted rock cools into an igneous rock. Depending on the cooling time of the rock, is based on the grain size. Sedimentary rocks are formed by compaction and cementation of different sized particles. As you can see in the sample of conglomerate, this sample of a particle is a lot bigger than all of these little samples. That is how you can tell it's a conglomerate rock. The river flows over the overlying bedrock, and then as the river's velocity goes down, the rock sediments are deposited. When the rock layers are deposited, it grows over time and gets layered together and compacted down to form many layers of different sedimentary rocks. With time, the sea levels change and the river goes through it, eroding away and weathering some of the sediments. The melted rock forms igneous rocks when it is solidified. There are many different igneous rocks, such as basalt, granite, pumice, rhyolite, andesite, and many different other types too. The igneous rocks are formed by melting and solidification of hot magma. The grain size of the rock depends on the cooling time. Fine-grained rocks were extrusive, and coarse-grained rocks were intrusive. Extrusive rocks have a shorter cooling time, so they are cooled much quickly than intrusive rocks. Fast-cooling magma results in air pockets. These are also known as vesicular rocks. As you can see in this sample of a vesicular rock, there are many different air pockets. 1, 2, 3, and then there's a lot of little other ones too. One example of a vesicular rock is pumice. Lastly, we have metamorphic rocks. Metamorphic rocks are identified by banding in layers. You can tell that this is a metamorphic rock because it has very significant examples of layering. As you can see, this layer is so much lighter than this darker layer over here. Metamorphic rocks are formed by the pressure of overlying bedrock pushing down on the bedrock that is being altered. When the heat matches up with it, it alters this rock over here. So if there was much mineral quartz over here, then this metamorphic rock would become quartzite. But say if there was no metamorphic rock over here, and there was only rock, it would become hornfels. Therefore, there are many different types of rocks. So, as you can see, that was the ways to identify the different types of minerals.